Alright, so Chapter 17, Part 4. We've talked about how glaciers form and how they erode, and now we're going to talk about what they leave behind, or their deposits. So, when we look at alpine glaciers, I've mentioned this, they leave behind moraines, and we'll talk about that. But one difference, and we know the difference between glacial deposits and river deposits. Remember how I said rivers sort by size? So they drop off the heaviest things first, and the lightest material is carried the farthest. Glaciers don't do that. The ice brings everything with it, big and small, and when the ice melts, wherever it is, it drops everything. So glacial deposits are what they call unsorted. If you dig through a glacial deposit, you have big rocks and small rocks side by side. Not so with a river. So a marine or moraine is just basically a heap of glacial sediments deposited by a glacier. The glacier pushes things with it on the sides and leaves it. And the moraines are composed of till. Till is just the kind of fill, it's unsorted. So we have several types of moraines. The recessional and the terminal are the two most important. So the recessional moraine is as a glacier moves out, as it begins to retreat, it forms a little bit of a recessional moraine. These are basically markers of where it was as it retreats. So it goes forward, then it kind of goes retreat, 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 retreat. It'll leave a series of recessional moraines. The terminal moraine is the recessional moraine that is furthest away. It basically marks the farthest the glacier ever got, so the end of the glacier. Okay? And we use these. We can look at these landforms, and we can tell several things. We can tell the history of an area. How far did glaciers expand? How far did they reach? And we can also use the dating. We can actually date these sometimes by some of the materials. And we can use that to kind of indicate when this area was glaciated. So here's an example. Here's a glacier right here. Here's a toe. This is in Argentina. And so here is the terminal moraine right here. All the stuff it's pushed right here. Just a big pile of dust. Right? That's called till. Here's the moraine that was on the side of the glacier. But the glacier's melted and left. And as the glacier melts, the water comes out. Any kind of water that comes out washes out here. There's usually a stream that leaves behind rocks and sediment as well. So we know that this right here was the furthest this glacier ever got. So again, here's a glacier, it's coming down. You have the toe, the edge of it right here. The lateral moraines, these are the ones that kind of just follow the side of it. But the big one here is the recessional moraine. Here is the terminal moraine, the furthest one out. Here's the recessional and another one. And they're like almost kind of a series of steps back. Okay. Now, when we look at North America, basically anything like Chicago and north all the way into Canada, these huge layers of glacial sediments. Because we know at one time, during about 15 to 20,000 years ago, most of the northern half of North America was covered by one ice sheet, which is now long since melted. Okay? So we see these ground moraines, and they're all over, they're kind of smoky and hummocky. Hard to see from the ground, but they're evidence of this. So here we go. This right here is where Chicago is. And this is the extent during the last ice age right here. So the ice sheet begins right here and expands, covers almost all of Canada. So basically from, let's say, New York and Chicago all the way across. Now there were other smaller ice sheets. This Cordilleran ice sheet actually forms here in the Rocky Mountains. They kind of met. The Greenland ice sheet was here. The only one left, by the way, the Greenland ice sheet. This is melted, and this is melted into individual mountain glaciers. There were also glaciers in Europe. There was a glacial ice cap here in Scandinavia that went as far south as Berlin, Germany, and through northern Russia. So this whole area, and then the water was covered with ice too. And how do we know this? Well, we look at some of the landforms left behind. So glacial ice sheets leave deposits that are a little bit different and unique to them that alpine glaciers don't. And the first one is a drumlin. So as this ice sheet's moving, right, this big huge chunk of ice is gradually moving, it basically carves these little hills and leaves behind hills, kind of very low and long on the surface. Here's an example right here. And those are only made by ice sheets. And we find these all over North America. If there is a stream of meltwater in the glacier, the sediment that it carries with it kind of gets sorted on the side. So here's inside the glacier what's called an esker. And inside this is a stream of melted water, and it leaves behind some sand and gravel. And when the glacier melts, it actually leaves behind this whole stream bed. You can see one here from a picture up above right here. And then oftentimes we'll see what's called kettle and came topography. So here is an area that is at the edge of a glacier, right? As the glacier melts, here's the moraine, right? A couple things happen. As it melts, some blocks break off, big chunks. And if they melt and they have a big enough hole, they'll form a little lake. They call it Kettle Lake. Sometimes the glacier melts and there's these big pile of sediment on top, like think about a big pile of dust or dirt on top. And as the glacier melts, it's left right here, like a big kind of hill of rocks, caves. And so if you see an area that has moraines and eskers, kettle lakes, and caves, looks like this. That's evidence that glaciers were here. Now, we don't see the entire area of North America covered with this because over time, other things erode this. But far, far north, the glaciers were here much more recently. There is an area in Wisconsin called Kettle Moraine State Park where you can see some of these features. But for the most part, they're in the far north. So we know that these recessional moraines, they kind of show you a series of where the glaciers were. They're hard to see from the ground. This is a map right here. These are all recessional moraines, so you can see that the farthest they got was right here. So this is the furthest the ice got. Little interesting note. Some reason right here in the middle of Wisconsin, during the last ice age, the glaciers went around this area. It never covered with ice. Something happened to make the glaciers split. We're not exactly quite sure what. But this area was never covered with a glacier. And so if you go here, this is the area where, if you've ever been to the west part of Wisconsin, La Crosse, Prairie du Chien, the Mississippi River, it is much different. It's very rugged, has very deep valleys. It was never carved and smoothed over by the glaciers like everything else was. But these moraines, by the way, usually are not easy to spot. There's a moraine that goes right through the middle of Chicago, but it's only about 1.5 feet taller than the surrounding land. So unless you're actually knowing what to look for, you would never see it. And another calling card is dust. So remember I told you that glaciers can actually grind rocks into dust called glacial flour? Well, sometimes that dust can get into the wind, and so the wind will blow it around and blow these big, huge deposits. They call it loess. And we see these across large sections of the northern hemisphere. And these, for the most part, were deposited by glaciers. Now, what's neat is that it's dust, but because they're so small, they have a lot of static electricity, they will actually clump together because of static electricity. But if you grab it, it'll just crumble in your hands. So over time, it looks like rock, but this stuff you could literally just put your hand through and pull it out. And it's a large chunk. About 10% of the world's surface and 30% of the U.S. has these deposits. It is important to note, not all of it's glacially derived. Right here in China, this is actually the result of desert winds blowing sand from the deserts. Okay, I'm going to pause right here, and next thing we're going to come back talk about polar ice sheets and the sea level.